are starting. So you guys need to be on page 108. So today we're going to talk about perpendicular and angle bisectors. Now, we actually did these constructions for semester. Okay, so your I can statement is use perpendicular and angle bisectors to solve problems, and some vocabulary you need to know about is equidistant. Equidistant means all the distances are equal from a point. Okay, we're not doing the model and discuss. All right, so our essential question: what is the relationship between a segment and the points on its perpendicular bisector, between an angle and the points on its bisector? So hold on, we're good. Okay, so it says find equidistant points. What it's saying here is how can you find points that are equidistant from the endpoints of AB? All right, what do you notice about these points and their relationship with AB? So if we recall the construction, all right, we have the segment AB. We would take our needle, put it here, and go above the halfway point, and we would draw an X above and below, right? So these points from here to here are equidistant to AB, and these points from here to here are equidistant to AB. All right, which means that length of these 2 points and the length of these 2 points end up being the same distance. Okay. Now we are not going to redraw these. I don't want us to redraw these. Okay. But we are going to have to, you see example 1, I want you to just cross this out. Just cross out, like don't just cross out the wording, not the whole space. We need the space for something else. So you want to just kind of cross this stuff out. Okay, that's it. And what I want you to do is underneath there, you're going to write 2 theorems. This is the first one, the perpendicular bisector theorem. If a point is on the perpendicular bisector of a segment, then it is equidistant from the endpoints of the segment. So if you have essentially segment XY and you constructed this to create that bisector, as specifically a perpendicular bisector, you would have XQ congruent with QY. And the thing you would know here is that PX would be congruent with PY, or those measures would be equal in this case. In order to prove the congruency part, you would have to use your definition of congruence. Okay. Show of hands who's still writing this down. Okay.
You say it's like somewhat stubborn. That's like the least of like.
Caught up? Are we okay? All right, here's the next one. Same idea, but again, the converse. So this is the converse of the perpendicular bisector theorem. If a point is equidistant from the endpoints of a segment, then it is on the perpendicular bisector of the segment. All right, so we're not going to do the proof for this one. We'll do the proof for the first one. So it says if, again, you have this triangle and they're saying that these 2 sides are congruent, then XQ is equal to QY and PQ is perpendicular to XY.
That's my first time ever going to Taco. I've never been back. It's not my first time. I've never bought one. Wait, I want to. It's not. I don't know. They do. But then it's
All right, while you guys are working on this, I want to give you guys a warning. A lot of stuff you're seeing second semester is going to again be applied in Algebra 2. Okay? So please do not delay on getting homework done or asking me questions. Okay? Because all they're going to do in Algebra 2 is they're going to be like, oh, hey, you covered this in geometry. Now we're just going to add more to it. Okay? So just an FYI, this is kind of the start of what you will see again next year. Sound good? Okay, anybody still writing this down? Okay, another minute. All right. Okay, so here's what I want you guys to do. For example, two, get rid of the word converse. Get rid of converse of the perpendicular bisector theorem, and I want you to write down this given, this prove, and this picture. Okay? You can write it down like this if you wish, but this picture will do just fine. And one thing I want you to do is connect these two, x to p and p to y. We're going to go over the proof of the perpendicular bisector theorem. I'm going to do it as a 2-column because this is, it's missing information. In fact, let me grab that picture. Okay. All right, so here's our picture. I'm just going to draw it real quick. We have X, we have Y, we have P. We have this line going through, which I'm just calling L, okay? And right here, we have point Q. All right, one thing they gave us is that we have, this is perpendicular, and we have XQ is congruent with QY. So, remember, we have our statements. We have our reasons. All right, first is our given. Our given is that L is the perpendicular bisector of XY. All right, so now that I know that, I'm going to state for part 2 that angle PQX and angle PQY are right angles. And that's by the definition of perpendicular lines. because of that, because they're both right angles, I'm going to state that angle PQX is congruent to angle PQY. And that's because all right angles are congruent. So right now I have my two congruent angles. Next thing I'm going to state is, now remember they say this is a perpendicular bisector, which means that this and this should be congruent to each other. So I'm going to put XY, or XQ, sorry, XQ is congruent to QY. That's by definition of a segment bisector. Part 5, now remember, we have technically this angle and this angle congruent, this side and this side congruent. The next thing we would have is that PQ would be congruent to itself. By the reflexive property. So how are these two triangles congruent? Who remembers? Yep. So we're going to say triangle XPQ is congruent to triangle YPQ. By side angle side. And now we're trying to prove that PX and PY are equal, not necessarily congruent, but equal. But we still have to use congruency because we're using CPCTC. All right, corresponding parts of congruent triangles are congruent. So I'm going to state that PX is congruent to PY by CPCTC. And then my last step is going to be that PX is equal to PY by definition of congruent segments. So remember I said proofs did not go anywhere. We're going to see them again. And we're doing this as part of the refresher. You might not see them this topic, but you will see them. Okay? Questions on that? All right, we are skipping example 3. Move on to example 4. Is there anybody still writing this before I get rid of it? Nope, this is not the example 4 I have. Hold on. Here we go. All right. For some reason, it says example 4 in your book, but it's example 6 on the slides. All right, let's talk about this. So we're going to apply the perpendicular bisector theorem. Okay. So it says, what is the value of AD? All right, so in this case, we have 6x minus 10. We have this perpendicular, and it looks like it's bisecting because each of these are 11, and we have 3x plus 2. Because AC is a perpendicular bisector of BD, we know that these two sides will be equal to each other. And we just proved that, right? So we're going to set those equal. We solve, we get x equals 4. When they ask for a specific side, you need to substitute it into that side. Yes, technically either one will work, but use the second one as your check if you need to. In this case, we're going to have 3 times 4 plus 2, which gives us 14. Okay, now we're going to try one together. So let's take a look at letter A. Remember, this is example 4 in your books. I don't know why it's like this in the slides, but we'll just go with it. So it says, what is the value of WY? All right, so in this case, they're saying we're going to have to apply the converse, which states that if we have these two sides equal, then this is a perpendicular bisector. So I'm going to have 5n minus 2 equals 2n plus 7. What does n end up equaling here? Who can tell me? Yeah. 3. Substitute that into WY. That's going to be 2 times 3 plus 7, which leaves us with a total of 13. So that's a pretty basic example of how this applies. Let's take a look at letter B. Now, if we look at this, we have to look at this as two separate triangles, okay? We see that this side and this side are congruent. So therefore, J to L has to be bisected. So that means NL equals 14. So then I have NM and ML. If we look at this triangle right here, NML, we have the same thing going on, which means N to O ends up being 7. So now they're asking us what OL is. Now we know that this is congruent to this, so that means, and we know that this is a bisector, so OL would have to be 7 in that case. Does that make sense? Questions on that? Anybody still writing? Okay. All right, so let's take a look at number 7, example 7. In this case, it's example 5 in your books. Find the equidistant points from the sides of an angle. An airport baggage inspector is most efficient when he stands equidistant from the two conveyor belts. How can the inspector determine where he should stand? So if we use the pairs of corresponding points on each conveyor belt that are the same distance away from the vertex of the angle, to be equidistant from the conveyor belts, a point must have the same distance from the corresponding points. So in this case, what we have here is we have this these two conveyor belts. We have these corresponding perpendicular lines that connect to different points on that conveyor belt. All right, so each intersection of the two perpendicular lines is equidistant from the conveyor. So what we're saying here is this is equidistant with this is equidistant with that, and this is equidistant with this, okay? So, and these 3 points right here end up being collinear because they all land on the same ray, okay? So since the pairs of right angles formed are congruent by hypotenuse leg, and if you think about that, there's your hypotenuse, and then these are the congruent legs. The theorem, the corresponding angles formed by the vertex angle and ray Q are congruent by CPCTC. Therefore, ray Q is the angle bisector. Okay, so the inspector can determine where to stand by choosing a point on that angle. So we bisected this angle and proved it was a bisector by using our triangle congruency rules. Now let's take a look at number 5. So what we're going to do is we are again going to I'm just going to kind of draw this out. So it says, consider 2 triangles that result from drawing perpendicular segments from where the inspector stands to the conveyor belt. How are the triangles related? All right, so if I drew this, so here's 1, 2, 3, 1, 2, just not go far enough. 3. Okay. We can look at this and remember, he can stand here, he can stand here, he can stand here, and we know that this and this are congruent. So if we look, all these triangles will be congruent by angle, angle, and then those congruent sides. Okay, so in this case, the triangles are congruent by angle, side. And this is leading us into our next theorem, okay? So we have the angle bisector theorem. And I want you to write this down either in blue, on the blue side, somewhere around there, all right? And it states, if a point on the bisector of an angle, if a point is on the bisector of an angle, then it's equidistant from the two sides of the angle. So in this case, this AD ends up being the angle bisector. Therefore, point D is equidistant from ray AB and ray AC. Okay? So this will be congruent to this, or in this case, it's going to be equal. Remember, the definition congruence determines equality. Show of hands who's still writing. Okay. I am going to create a foldable for you guys. I just haven't had a chance yet. So it's coming. But in case it doesn't, at least this way you still have the copy in your book. Or if you lose the foldable, that's another thing that happens.
If I get this wrong,
how are we doing?
that's just a normal font, right? Yeah, that's what I thought. See that trash can over there? Fill it. Stick your computer.
All set? Here's your converse. Write this in. If a point is equidistant from two sides of an angle, then it is on the angle bisector. So they reversed it. They're saying, hey, if these two are equidistant, this guy has to be on the angle bisector of BAC, making measure of BAD and CAD equal to each other.
Did we get benefits in school? How did like the first day? You have to get rid of like just get shit.
Am I still writing? Okay.
And you're doing because I switched to this to make the negative. Yeah, that's exactly. In the hall. Do you have motion? Oh, you went down the hall. Oh, in the hall. They were like really.
It was the gym. The gym was my love science.
Finals were pretty good in here.
Yeah, I was very surprised when I got my lowest one. But final was an 85, and then all the other ones you have a 90.
That's good.
And it was just
Yeah. That's rules to remember.
I mean, I don't really care if this one.
All right, let's talk about example 6. In this case, this is example 6 for you guys. So we're going to apply the angle bisector theorem. So it says, what is the value of KL? So again, remember, they're saying that this is bisected. That means this point lands on the angle bisector. These are perpendicular, so these two should be equal to each other. When you set them equal to each other and solve, you get x equals 7. Substitute in, you get 17. Okay, so looking at example 6, we're on example. You're looking for example 6. What, Evan? Did you say where is that?
Yeah.
You're good now?
Yeah.
Okay, just checking. All right, so it says use the figure shown for A. So we're going to use this for A and B. I recommend 2 colors if you're using the same picture. If HI equals 7 and IJ equals 7, and the measure of HGI is 25, what is the measure of IGJ? That should be pretty easy because if you look at it, guys, thank you. HI and JI are equal to each other. So that means that I is landing on this bisector. So the measure of angle IGJ will be 25. Now for letter B, if the measure of HGJ, so this entire thing is 57, IGJ is 28.5, and HI is 12.2, what is the value of IJ? Well, the first thing we need to do here is we need to confirm that this is actually bisected. So I'm going to take 57 and divide it by 2, which actually gives me 28.5. Now that I know that this is bisected, I know these two end up being congruent. So in this case, IJ is going to equal 12.2. Questions on that? All right, look at page 112. I want you guys to work on 5 through 8 on your own. Look at 5 through 8. We'll go over those in just a few minutes.
You're ruining it. I don't think you're putting everything there. It's a word. It is. That word public.
Oops.
As a group of users. Mine was like that's the illustrated.
No Gavin today?
Yeah. Yeah.
You should like do that. Right?
Yeah, I did.
What's up with Gavin?
I don't know. Probably sick.
Oh boy.
Or he did say it's back. Right here. Oh, just give him whining about it today.
I forgot.
Slow down.
I could have gone.
Guys, the reason I lost sewer is because my back hurts. I can't hold on anymore.
Way too long.
He said,
Being someone who currently has back pain, get it. Like everyone's making fun of, like Mr. Draper made fun of me this morning because I had 2 of these, and he's like, "You thirsty or something?" I go, "I'm tired because I'm on like 2 hours of sleep. Being on 2 hours of sleep is not fun." Yeah, sure. Show of hands, who's still working on 5 through 8? Anybody? All right, someone tell me. All right, shout out number 5. Who's got it? Is he? 10. Nice job. How about 6? 6, 6, 6. Someone new. Go ahead. 4. Nice job. 7. Someone new. No offense, Izzy. Love it though. 4. 7. Who's got it? Show me 7. 36. Nice job. And someone new for number 8. Ooh. And the class falls silent. That's a good question. Is that what you just said? It's okay. So, what is the algebraic expression for the area of the square picture and frame? All right. So we know these are congruent. So this is equidistant. So therefore, we know if that's x minus 2, this side is x minus 2. We know all sides are equal in a square. So we're going to have x minus 2 plus another x minus 2, which gives us 2x minus 4. But we're finding the area of the square, which means this is 2x minus 4, quantity squared. That's it. Questions, comments, concerns? Snyder marks. Keep going on your homework. Those who watching at home, have a great day.